Okay, so welcome members. Today we are going to see how do we apply laws, stock properties from logarithms to solve such questions. But please don't forget to subscribe to the channel. Now, start with, before you handle such equations, you should make sure that all the terms are to the same base. Look at number 1 here. You start, it has base 2 and base x, so the bases are not the same. So the first step is to make the base the same. So start, this one is 2, the figure here is 2, and here the figure is 2. So there what you need is just to change the base. It's better always to have the base as a figure. So the property we are going to use there is log of a base b is equal to 1 over b. You see, it has changed now to log of b to base a. So this property is what you use to change. If you want to change the base, this one comes here and this one comes here. This is the property you use. So I'm going to use it here so that I make this one go up and this one goes down so that I can easily simplify. So if I'm to apply it there, I have now minus. Now if I apply this property, equaling to 2. So after me applying this property, now the rest is now it's the same base with the same base. And it's better always to be a figure. Now what I do is that this one is common, so I say let m be log the common base, I mean the common logarithm, which is x to base 2. Now I'm going to be happy now, where is this? I put it here. M minus 1 over m equaling to 2. Now multiply through by m to remove this. So here we are in 3m squared minus, multiply here m, I have 1 equaling to 2m. Bring everything this side. Minus 2m minus 1 equaling to 0. So two numbers, multiply you get negative 3. When you add you get negative 2. So instead this will be 3m squared minus 3m plus m minus 1 equaling to 0. So that's how you can factor this to that. When you simplify, I'm sure it will go back there. So that here 3m is common. So 3m into m minus 1. Here it's 1 only, minus 1 equaling to 0. So this is common, so we have now 3m equaling to 0. So either my m is a 5 or my m is 1. But what was it? You come here. You know that when m is 1, what are you going to do? You say, first of all, you log x2 is equal to m. So this would be equal to 1. Now here I am going to apply the property which says that if you have log of a base b equal to c, then this is the same as a equal to b power c. So I'm going to apply this property. So this will be now this power this. So x will be 2 power 1. When you apply this, you get this power this will be equal to this. So this power this will be equal to this. And your x here is a 2. Now when I come to when m is a third, so that now I have log x2 equaling to a third. So the same property, my x will be 2 power and a third, and you can give it to some decimal places you want. So for the decimal places, the cube root of 2. So this one is giving me 1.2599 for the small places. So now, when we come to this one now, we start here, the same thing, the same base. I mean, you see, we have a 5, we have a 5, but the base is not the same. So we make sure that the bases are the same. You see that this one is having now this kind of coefficient, but I don't mind about that. I want now to push this 5 down. I told you it's always better to have a figure as the base. So the same property, so this is 5, this is 5. So the same, I'm going to say now this is, then plus, don't mind about 2, it's just a coefficient, then 1 over, if I get L reciprocal, now this one changes to this, and then this one comes there. This one is going to go up. The whole is equal to 3. Now you see that this is common. So I say, let log x 5 be any letter. You can say now let it be k. So we select. So from here I put k, then plus 2 over. So 1 times this you get 2. This one is k, equaling to 3. Multiply 3 by k squared plus 2 equaling to 3k. Take this side, we have k squared and then 3k plus 2 equaling to 0. And I bring this side. Two numbers, I multiply, I get 2, I add, I get negative, I get negative 3. Those are x minus 2, then k minus 1 equaling 0. So your k here. But what was your k? From here, say your k. So from here, when your k is 2, you know that we'll be having, if we apply the other property, it says log AB equaling C, then your A will be B power C. So from here, so now I have log x 5 equaling to 2. So my x will be this 5 power this 2, and your x there is 25. When I come now when k is 1, I'll be having log x 5 equaling to 1. So that now my x will be 5 power 1, and my x will be 5. So those are the values of x. Now, when I come to this, now this one is at the base is not the same. This is 3, this is x, and even this figure is not the same as that. These ones, the figures were the same, just that we just had to change the base. But this one, the base was the same, and here even the figure was the same. But here, the base is not the same, and even the figure is not the same. So we first make that log be having the same figure. Now the property that we are going to use is this one. If you have now want to change to a new figure, so here I want to introduce 3. I want to introduce also a base 3 here. So if you have to introduce a new base, this is the property you can use. So it says if you have log A, base B is the same as log up, the base you want to introduce, also down B, then the base you want to introduce. So what I'm going to do here, now I want you always introduce the smallest base. So starting here, you see that 3 is smaller than this figure here. So I'm going to introduce log to base 3. So here is the same. Then minus, now this, applying this property, I have now log 27, 3 over log x, then 3 equaling to 2. Now these ones are very easy. You just ask yourself, what should I raise to 3 to get 27? As simple as that. You don't need to do a lot of work. So x 3 minus, what should I raise to 3 to get 27? Is that if I get 3 and I power it 3, I'll get 27, meaning that all of this is giving us a 3, then over log x 3 equaling to 2. Now the same, now it's the same now step. We have the same thing. Now you remove this one and make a quadratic. So you say let element of the trace be log x base 3. This will be now p minus 3 over p equaling to 2. What price through by p? Take this side. So two numbers multiply, you get negative 3 and you get that. Those are p minus 3, then p plus 1 equaling 0. So either your p is 3, or your p is negative 1. So when p is equaling to 3, from here you have now your log x3 equaling to 3. This will be now x 3 power 3. To the power 3, that I think is 27. And then when you come to when p is equal to a negative 1, now you have, when you take it up, your x will be 3 power negative 1, then x becomes 5. So members, that's how we can solve these equations. Don't forget to subscribe to the channel. I wish you the best. Sign out.